In OpenStax Calculus Volume 2, we are working on trig substitution problems, and we've done the square root of a squared minus x squared, the square root of a squared plus x squared. Now we're going to do the square root of x squared minus a squared. So in this case, we are going to replace our x with a secant theta and our dx with a secant theta tan theta d theta. And so when we evaluate our square root of x squared minus a squared, we're going to end up with a tan theta. But we're still going to work it out the first few times just to make sure. All right. I will also come over here and remind you that if we have x equals a secant theta, then x over a is my secant. And that means that it is hypotenuse over adjacent. And that means x squared minus a squared. Yeah, is my opposite side. So if you ever really wanted to, you could sit here and say sine theta equals square root of x squared minus a squared over x. My cosine theta is a over x. My tan theta is opposite over adjacent. And then you flip them over for cosecant, secant, and cotan. All right. Find the area of the region between the graph of f of x equals square root of x squared minus 9 and the x-axis over the interval from 3 to 5. So we know we're going 3 to 5. The area between these two, you would do square root of x squared minus 9 minus 0 for the x-axis, but we don't need that. Dx. We're going to use x equals 3, because square root 9, secant theta, which means that dx is going to be 3 secant theta, tan theta, d theta. Remember, we're not going to put our 3 and our 5 back on there just yet because we're changing everything from x's to theta. And if we used our 3 and our 5, it would not be accurate anymore. So square root of 9 secant squared theta minus 9 times 3 secant theta, tan theta, d theta. Right here, we get this, which is 9 tan squared theta. So when we take our square root of that, we have 3 tan theta times 3 secant theta, tan theta, d theta. Okay, so we have 3 tan squared secant. Turn that back into secant squared minus 1. Ah, guess what? I just realized I made a mistake right here because when I multiplied this 3 times this 3, it should have been a 9. Sorry. Just wanted to fix it while I was thinking about it. Times secant theta, d theta. So we have the integral of 9 secant to the third theta minus, and I'm going to separate this, put a d theta there, 9 secant theta, d theta. And the reason I did that is because we've integrated secant to the third so many times already that we already have that information in our notes several times. All right, so here, in order to change my 3 and 5 as my limits, since we had x equals 3 to x equals 5, so if we say 3 equals 3 secant theta, divide by 3, 1 equals secant theta, that happens at 0. When we have 5 equals 3 secant theta, 5 over 3 equals secant theta. We don't know 5/3 right off the top of our head, so we're going to say inverse secant of 5/3. So our limits of integration for this are 0 to inverse secant 5/3. 0 to inverse secant 5/3. All right. So when we take our actual integration, Secant to the third, like I said, is in our notes so many times. It's the 1/2 ln secant theta plus tan theta plus 1/2 secant theta tan theta. So we're going to put that 9 in there. 9 over 2 natural log secant theta plus tan theta plus 9 over 2 secant theta tan theta minus, for secant theta, when I integrate it, I get 9 ln absolute value of secant theta plus tan theta. And all of this is from 0 inverse secant 5/3. All right. Now, in order to plug all of this in, I could put it in my calculator. It would give me a decimal. I'd be finished. However, we want to know how to do things. That's our goal here. So if I say secant inverse is 5 over 3, then that means we have hypotenuse over adjacent. So a little right triangle here with a random angle theta. Hypotenuse is 5, adjacent is 3. If you do the Pythagorean theorem, that means we have a 4 here. Okay? Now, the reason I did that is when we plug in 9 over 2 ln, when I put in secant inverse 5/3 here, the secant and the secant inverse cancel each other out and give me 5/3. Plus, when I do tan of secant inverse 5/3, well, if the secant was 5/3, the tan is opposite over adjacent, which is 4/3. Plus 9 over 2 times 5/3 times 4/3. Oh, I forgot that one. Minus 9 ln of 5/3 plus 4/3. I should have combined that before I started, but that's okay. Now, if I put in 0 everywhere, 9/2 ln, absolute value, the secant of 0 is 1. Tan of 0 is, sorry, I'm looking at my stuff and trying to work at the same time, 0 plus 9 over 2 times 1 times 0 minus 9 ln 1 plus 0. All right. 5/3 plus 4/3 is 9/3, which is just 3. So I have 9 over 2 ln 3 plus, multiplying all of this out, that cancels here. That's 20 over 2 is 10 minus 9 ln 3 minus 9/2. Ln 1 is 0. So this is 0. This is 0. This is 0. So my 9/2 ln 3 minus 9 ln 3 is negative 9/2 ln 3 plus 10. Final answer.